If you're in your data science or AI journey and are going for interviews, then you could be expecting questions from different areas such as machine learning, natural language processing, deep learning, or generative AI. Now, that depends on two major criterias. The first criteria is what the company is looking for. Are they looking for people with more predictive AI knowledge, or with more knowledge on neural networks or generative AI? And based on that, you have to curate your resume in a way that it goes through the initial screening process and you are shortlisted for the technical rounds. And the second criteria is what I just explained. You need to have those skills what the company is looking for, not what you actually have. Now, for an example, if you are going for a interview in a telecom company and they are looking out for experience into generative AI. Now, if your resume is filled up with predictive AI and especially dealing with different other domain expertise on financial industry or insurance industry, then it is less likely that your resume will go through. Anyways, coming to this topic on interviews, if you have made it through to the initial rounds of screening and you have been called for a technical interview, that means your resume resonates with what the company is looking for. Now, when it comes to interviews, as I told, there can be different areas of research that could be asked, right? Machine learning, deep learning, or generative AI. Now, we are going to create a series of videos on interviews. This video is dedicatedly created for machine learning. That means if you are looking out for the top 10 machine learning interview questions asked in interviews, meant for freshers, intermediates, and even experienced professionals, or even people with 15-20 years of knowledge who wants to switch into managerial roles of data science or AI, this video is going to be a one-stop solution. In the next videos, in the follow-up videos, we will be creating videos on deep learning, natural language processing, generative AI, and so on. So if you like this concept that we are coming up with such innovative videos, please like, share, and subscribe the channel. And one major announcement is awaiting. Please watch this video till the end so that you can avail that announcement. What is going to be announced will be talked at the end of this video. See you in the video and enjoy. What criteria would you use to select the most suitable machine learning model? Well, this is a very generic question, but there are different ways and different style an interviewer would ask you. Now, for example, one of the ways of asking is, let's say the interviewer is going through your profile, your resume, and you have mentioned you have worked on a churn prediction model, right? They could ask you, oh, I see you have worked on a churn prediction model for a telecom company in the past. So which model performed the best in this case? And you will say, oh, sir, it was random forest. And then the follow-up question will be, how? How did you come across or how did you finalize random forest to be your best model? So that is exactly this question, right? Now, before getting into the answers, as this is the first question in this interview series, I would like to give you some generalized tips. Okay. Now, interviews are usually technical interviews are for 1 hour, right? 60 minutes. But as an interviewer, in the first 15 to 20 minutes, I usually make the decision whether this candidate is good or not. And in my case, if the candidate is good, I keep pushing for 1 hour. I keep asking him more and more challenging questions. But if I see that the candidate is not good enough, there will be a change in body language, and potentially in 35 to 40 minutes, I will try to wrap up the interview, right? So, as an interviewee, you should be able to interpret the body language of interviewer and see whether you have done well or not, right? Now, in an interview, usually the first 5-10 minutes goes in introduction. Interviewer introduces themselves, talks about the company, blah blah blah, and then asks you to introduce, right? So 5 to 10 minutes is gone there. Now left is 50 minutes. Out of 50 minutes, the very first question they will ask you is going to be one of the projects that you have worked on. make sure you explain them in a proper way. Take at least 10-15 minutes to explain. And when, so my strategy is very simple. When I am attending a virtual interview like this over Zoom or over Google Meet, I make sure that I have access to a whiteboard, either Miro or simply paintbrush. I am very confident on writing just using a mouse, so I usually write using mouse. Now, in case you are not good in writing in mouse, try to take a digital pen. I think it's available in the market, digital pen, and you can just USB, via USB you can connect and you can just write it, right? Should not be a big problem. And if you're going for a face-to-face interview, make sure you have access to a pen and paper or else whiteboard. The reason is whiteboard explanations are more impactful. To answer a question, if you just theoretically answer like this, I would potentially be able to answer it in 5 minutes. But when you're whiteboarding it, you will be focusing more on those points that you already know. And in an answer, you can potentially hide the things that you don't know. So, for example, in a process of machine learning, you are not sure about hyperparameter optimization, you are not confident. So, you potentially can talk less about it and more about the terms or concepts that you already know. And by drawing, it is more impactful, right? So, these are some tips, very generic tips applicable to everything, right? Because if you give short answers, potentially you will be getting more questions in the interview. So it's always better to elaborate as much as possible. Now jumping into the question, so how would we answer this question? Which criteria would you use to select the most suitable machine learning model? Now as a candidate, what I'm going to do is I'm going to tell. So I'll take an example. Maybe so in machine learning there are different type of problems, right? There are classification problems and there are regression problems. There are clustering, association rule problems, various other things. But let's just focus on classification and regression. So what I'm going to do is I'm going to take one of the examples from the past. Always answer a question by giving a real life example. If you are an experienced professional, take example from your previous companies. If you are an fresher, take examples from your previous internships. If you don't have any internship experience, take examples from the projects that you have done. Do not give random examples where you have worked on. Okay, so how I would answer is, so to answer this question, we'll try to take an example of a classification model. So in 2019, I was basically working for a company called as HEC. It's a telecom broadband company, and the problem statement is very simple. It's a telecom churn prediction use case. Telco customer churn prediction use case. Now, my manager, basically I was directly working under the chief digital officer, and upon understanding the problem statement, we identified that the churn rate of the company is around 28%, which in telecom terms is very high. Usually telecom churn rates are around 20-22%, not more than that. So HGC's churn rate was 28%. Now as a data scientist, I was given this task to first of all analyze the data, who are the potential churners, do a proper EDA, and then eventually build a machine learning model, right? So I'll try to skip the EDA part because the question is more around how to choose the best machine learning model. So what I will do is I'll try to explain you the entire process of how I build the model. Okay. Now in this example, I'm just arbitrarily taking, so let's say we have a data set of 1000 records. Okay. Now of course there are different features, customer age, customer location, usage, price plan details, multiple telecom related features, and a y variable which talks about whether the customer is churned or not, right? Now what we did was we divided the data into training and test. So let's say training had 800 records and testing had 200 records, right? Now even from training and test, the split was equal. Around 72% of the customers were active, 28% were churned. So it was a stratified sampling, right? Stratified ratio. So 72%, 0.72 multiplied with 800. So around 576 active customers, and rest around 224 churned customers, right? Similarly here also, like 72 multiplied with 200, around 144 active customers, and rest 56 are churned customers, right? Now what we did was we took this data, and of course there was a lot of feature selection, feature engineering processes that we have done. uh, the very first step is building the initial model, but eventually we did feature selection, feature elimination, extraction. A lot of things were done, feature engineering processes. We also hit and trial with PCAs, LDAs, blah blah blah. We can talk about it if you are more interested on PCAs and LDAs, but for now, do not emphasize more on this part. Again, repeating that if you do not know PCA, you do not know LDA, never use that term. Just skip that part. Tell feature selection we have done, various other processes we have done, and we directly jump into the model building part. So if you know PCA, then focus on that part, because you have to make sure that the next question from the interviewer should be PCA. So you can focus more on PCA, right? That's how I drive interviews. I do not let the interviewer drive the interviews. I drive the interviews. Whenever I'm giving an interview, I make sure that the next question is predictable. Okay, so jumping into the answer, and then we built models. So there were different models that were built. So decision tree models were built, knife based models were built, several other models were built, XGBoost models were built, and every model gave some sort of performance, like let's say 80% accuracy, 82% accuracy, 83%. XGBoost gave us 89% accuracy. So from here we basically, let's say random forest gave around 88% accuracy. So we took around 2 or 3 different models, and then we did some hyperparameter optimization. And again, if you are confident on this part, talk about it. Randomized search is there, grid search is there, Bayesian optimization techniques are there. So based on that, we did some hyperparameter optimization techniques, which is again a very extensive process, very expensive process, because it is very time consuming. And out of this process, XGBoost was the one who gave us the best accuracy of around 92%. So this is the model that we have selected. Now we deployed this model for at least 15-20 days. The model was under monitoring. So whatever live data was coming, we were actually doing the predictions. Taking the live data, we were talking to the sales team whether this was actually in the list or not, list of churn customers, and the sales team was able to validate it, whether the model is working fine or not. And that's where we concluded the model is working fine. We deployed the model, and model deployment was done. This is how the model selection process was done, and XGBoost was one of our best models that we have worked on. Okay, so that's how you're going to ask, and there are at least 5 to 6 follow-up questions from here, and some of the follow-up questions are, yes, around PCA. Some of the following questions are around HPO. Some of the following questions could be around deployment. Okay, how did you deploy these models? Can you talk about the monitoring part of it? So we will be talking about various other interview questions. Moving on to the next question. In the previous interview question, we were talking about the model selection part. We took an example of a classification model, and we talked about how the model selection works. Now from that particular question, as I told you that because interview processes are not like robotic, right? They will not ask you one question from classification and directly jump into some other topic, right? They will be asking you follow-up questions, considering that the interviewer is knowledgeable. If the interviewer himself is not knowledgeable, he will ask you complete random questions, right? But logically speaking, when the interviewer is knowledgeable, usually they will be asking follow-up questions, right? Now, from this particular example, if I am the interviewer, I could potentially ask at least 4 to 5 follow-up questions, like, can you talk more about the feature engineering processes that you did, or can you talk more about the hyperparameter optimization that you did, or can you talk about deployment that you did? So all of these follow-up questions will be a part of this interview series. Slowly in the future videos we will be talking about it. But one of the most important question that I would be asking is this part. I talked about accuracy, right? The model accuracy. But can you see that the model is hugely imbalanced, right? 72 is to 28 ratio is the distribution of the y variable, right? These are your churn customers, these are your active customers, right? Now, in case of imbalanced data sets, do you think accuracy is important? Now, this is all about this question. If you are dealing with a highly imbalanced classification data set, what approach would you take and which evaluation metrics would you apply to assess the model's performance? Okay, now first of all, I would like to say that when the data is imbalanced, in this case we do not use accuracy as one of the metrics. Now, the first question's answer was just a brief demonstration, right? This is not actually correct, as in we should not use accuracy. We can use recall, we can use precision, we can use area under ROC curve, we can use other metrics, but not accuracy. Why? Because accuracy is cursed when it comes to imbalanced data sets. Why? Let's try to first understand why, and then I will tell you how to deal with these kind of problems, right? First of all, let's take an example of a very highly imbalanced data set. Let's say I have 1000 records. 990 records belongs to class A, 10 records belongs to class B. Let's say I created a Python script. Okay, in this Python script I have just simply mentioned whatever the data comes in, predict it as class A. Now what will happen? 1000 records will come. Out of them, 1000 records will be predicted as class A, right? So if I draw the confusion matrix, actual A, B, predicted A, predicted B. Actual A is 990, predicted A is 1000, right? So actual true and predicted true is 990, right? Actual B, so how many actual B? 10B, but predicted as A is 10. Actual A but predicted B, 0. Actual B predicted B is also 0. Now in this case, what will be the accuracy? The accuracy is 990 divided by 1000, which is 99%. You can see I have not created a machine learning model. With just a simple Python script, I am able to get 99% accuracy, right? What I'm doing is I'm just predicting everything as one class. Similarly, if I go back to this example, if I predict everything as active, for all the customers I predict as active, so what will happen? 200 predictions will be active, right? So what will be the accuracy? The accuracy will be 144 divided by 200 into 100, which is 72%. Not bad, right? 72% accuracy is good, not bad. Now, this is why accuracy is called as cursed in imbalanced data sets. So, either you go for recall, precision, F1 score, other metrics, but not accuracy, right? So, it is very, very important for models uh, to actually treat imbalanced data sets, because if data set is not balanced, apart from accuracy being cursed, models can be biased as well. So I'll give you a simple example to understand and grasp. Okay, now imagine there is a small baby, right? Now, who trains a baby? A newborn baby. Mom, mother, father. These are the two people who train. Sometimes grandmother and grandfather, right? um, so let's say a baby sees a cat quite often. Every day the baby sees a cat in the house. One or two cats keep on coming and going, right? So let's say 1,000 times the baby has already seen, the baby's brain has already seen. But horse, the baby has seen just 2 times. Let's say in the span of 6 months the baby has only seen horse for 2 times. Now, simply asking, if the baby sees a next cat, will the baby be able to identify it as a cat? 100% sure it will be able to identify. If the baby sees a horse, will the baby be able to identify the horse? No. The reason being, the baby's brain is not fed with enough data. Data is imbalanced. But if you balance it out, let's say from two, let's say you create multiple copies of images. Let's say I'm going to talk about an image. Let's say okay, this is one example, right? So let me create a folder here, test. Now, so let's say this is one of the images. Okay, now I'm going to create another image. Now in this image, what I'm going to do is I will be editing it, and let's say I'm going to crop it. Let's say I'm going to add some, I'm randomly doing something and I'm just saving it, right? And in this image, let's say I'm going to imagine I'm going to reduce the pixels. So from 938 kb it becomes 400 kb, but eventually all the three data is same, right? Like, you are able to identify me, you are able to identify the text, right? So what I'm trying to say is, imagine out of two images you do some copy paste, zoom in, zoom out, various techniques are there, and make 1,000 images. Now when you train this data, your model, your brain takes equal amount of information from for both these categories, and your model is able to balance out the data, and the model is eventually going to perform better as compared to the first case. Okay, and that is why balancing out data is very, very important to reduce the biasness, right? So imagine you are working on a fraud detection use case, millions of transactions, and let's say 990k good transactions, just 10,000 of failure transactions. Now if your model is getting trained, the model is highly trained on class A, but for class B only 10,000 records, so the model is not able to identify the characteristics. So if you want the model to be good enough, you need to feed equal amount of data, then the model will be able to perform better, right? So to answer this question, it's very simple. Again, take real life examples. How would I answer is, okay, so I was working on a telecom churn use case. Again, the data set was around 72 is to 28. Now imagine there are 1000 records. What we did was we first divided the data into training and test. So around 800 records here, around 200 records here. Now out of 800 records, so how many were active? 576 and 576 were active and 224 were churned, right? And from 200 records, 144 and 56. 144 active and 56 were churned. Now what we did was we balanced out this data. So always remember, when you are balancing out, only balance out the training data, not the entire data. Why? Because if you balance out the entire data before the training and test split, so imagine you are balancing out here. So 720 records for class A are active and 280 records for churned. If you balance out the data, let's say this becomes 720, this becomes 720, and after that you do training and test split, some of the copy pasted data that you have created could be a part of training and test, right? Now imagine some of the data are already a part of training data. That means the model already knows the information about this customer. So by default, the model will be able to predict them as churned, right? Think about it, right? So you only have to balance out the training data. Now balancing out can be done in multiple ways. Again, it comes down to experience. If you have an experience, you can talk about SMART. So there are different techniques called as SMART ENN, ADASIN, various cost sensitive classifiers. So many techniques are there which basically help you to balance out the data. Again, toss these topics only if you are aware of it. If not, do not. Generally, how would you answer if you do not know these topics? So generally you can tell, oh, there are multiple ways of balancing out. So let me explain you some of the techniques. One of the technique is upsampling. Okay, upsampling means you already have 576 active customers. From 224 you are actually recreating 576 records of churned customers. Now you are feeding a model. Let's say I'm writing down as model 1. It could be a decision tree or a random forest model, and then you are passing this, and let's say your accuracy is 79%. Similarly, you are creating a model 2, let's say a random forest model, and you are passing the testing data, and let's say your accuracy is 83%. So this is upsampling. Downsampling basically means for churned customers, let's say you have 224 records. For active customers, you arbitrarily choose only 224 records, and now it is balanced, and then you create model 1, model 2, and then you test it on the testing data, and you check your accuracy 78%, 79%, and so on. So these are two traditional techniques, upsampling and downsampling, which can actually fix balancing out the data problem, and then you can use accuracy as your metrics. Now in my example, I have actually done upsampling and I was able to get good accuracy. So this is again up to experience on how to answer, right? Always use your own experience to answer this. If you do not have any experience, answer the way I am answering, right? Explain them upsampling and downsampling, and then tell. In my case, upsampling was kind of giving us better results, and then we choose random forest because random forest here was 83, here was 79, it was bit low. We took this, then we did some hyperparameter optimization, and we were able to get around 89% accuracy or 90% accuracy. That's it. The third question is, have you implemented any classification models in a production environment? Again, one of the follow-up questions from the first question, right? And it could also come out of nowhere without even the first question. Directly the interviewer can also ask you this question. Very important question, and has numerous answers. It literally has 1,000 answers, right? Depends from experience to experience. Now, assuming that you do not have experience on production environment, on how models have been pushed to production and how to answer this question, I will try to help you out. So we will take the same context, churn prediction use case. So again, the same context, we have a churn prediction data set, and then we are dividing it into training and test, and then we were doing some feature engineering processes, and then building the model. Let's say model 1, model 2, dot dot dot, sorry, model n. Let's say we choose one of them, do the hyperparameter optimization, and then create a better version of model 2, and then we are deploying it, right? So the question is, how do you deploy, and of course, how do you monitor their performance, right? So I will talk about my case, right? So in this case, I was working in a company called as Hutchison Group, HGC. Now what we did was, so we were using AWS as a cloud service, and then we were using MySQL databases. So what I'm trying to do is, what I'm trying to help you out understand is, first of all, make sure that you tell the interviewer about how the model was deployed, right? Eventually, when your model is created, are you saving this model as a pickle file or as a hyper file, or what sort of extension you are doing? So as a simplest example, you can take help of .pickle file. You just tell that, let's say our model is prepared from 2020 till end of 2024 data, and eventually we have created a pickle file, right? Pickle file is very simple. Whenever there is a new record, you just have to call the pickle file, just load it. When you are loading the pickle file, basically you are loading the model, and then directly on top of that record you can do model.predict, and it will be able to predict you whether it is a falling in class 0 or class 1. Based on that, you will be able to understand this is class 0, which means it is a active customer, right? So always tell the interviewer, first theoretically explain them how the models are pushed into production, and tell the motive of the models, like whether the model is a real-time model, or do you run it every weekly or every monthly. In this case, it was a month by month run. So so the use case for us was, it's a churn prediction use case. So let's say my data is from 2020 till 2024, and imagine I'm running the model on Jan 2025, right? Basically, I'm doing a prediction for Feb 2025, right? Whether the customers who are active in January are going to be churned in February or not, right? So ours is a monthly, like a monthly, once every month we have to run the model, right? So we were storing the pickle file in our s3 instance, like s3 bucket, and then data was stored in MySQL databases. There was a trigger that was written. So trigger basically pulls data from, so basically the trigger is getting called once every month. Imagine today is the last day of the month, let's say January 30. The trigger is triggered, and then it calls the model. Let's say 200 customers have been included in the month of January. Along with that, there are some historical customers as well who are still active in the system. So for all of these records, we basically run the model. We call the model pickle file. We do the prediction, and the prediction is done. The prediction is also stored in MySQL databases. So by month, January 30, it gives a prediction for the end of Feb. So let's say out of this X number of customers, let's say there are 1000 customers, right? Out of these 1000 customers, let's say 500 of them are being predicted as churned, right? Now out of this also, we were doing predict proba, basically probability. So it is not directly 0 and 1, it's basically giving you probability score, right? So anybody whose score is beyond zero point 0.8, let's say out of 500 there are 100 customers who are beyond zero point 0.8, that means model is predicting with 80% probability that these 100 customers are going to be churned, right? And between the score of zero point 0.6 to zero point 0.8, let's say there are like again 100 more, and zero point 0.4 to zero point 0.6 are around 300 customers, and less than zero point 0.4 is around whatever the number of customers, we don't care, these are all active customers. Zero point 0.4 is basically our threshold that we have set based on our experience. That means anything greater than this is churned, anything less than this is not churned, right? So based on this list is basically generated at the end of every month. It is being sent to the sales team. Now sales team traditionally also has some mathematical, they also have their own calculations. They actually create their own sheets where they identify some potential churners, and then they reach out to them by telecalling and understanding their, what's going on, are they happy with the service or not, and then that's how they basically do the converting part. If somebody is unhappy, they give them offers to retain them, right? So our task is still here, we give them this list, they basically compare with their own list, whoever, whatever number of customers are actually common in both, they basically call them, and these customers are also high prioritized. So this is how we have deployed our application, and this is how you can answer. Now again, as I told you, there are hundreds and hundreds of answers with respect to Azure, AWS, on premises. Let's say uh, you have used AWS Lambda functions, you have a front end application. From front end some call is getting triggered, that trigger is basically calling a Lambda function. Lambda function is eventually your own model notebook where you are doing some activities, getting some response, and the output is getting fed to the front end. So it depends from architecture to architecture. So if you have not worked on any sort of such production level architecture, you can just cook up a story and kind of tell something like this. Recommendation for those who have not worked on production level environment is, whenever you work on a machine learning or a deep learning project, make sure you are creating a Flask application out of it, because Flask basically helps you to understand on what is actually happening. For example, when do we use Flask? Let's say you are working on a classification project, right? You have created your Jupyter notebook. Then the next step is you basically use Flask to create an API, right? And then when you are calling the Flask application, basically a front end is getting open, and front end is all about JavaScript and HTML, right? HTML, CSS front end, right? Based on the templates. And from the front end, let's say you are filling up some details and then you are submitting it. When you are submitting, basically a HTTP call is being made to the Flask application based on what type of call you are doing, post call or a get call. And then the Flask application is basically calling the backend module, doing some activities, doing the predictions, and the predictions are being provided to the front end. So Flask application basically helps you understand on how real-time things work, right? And then if you learn how Flask works, you can actually cook up your story even better, right? So that's it. That's all about this particular question on productionizing. How do you monitor their performance? Monitoring is done in a very traditional way. We have written down scripts where we are monitoring all the metrics like accuracy, precision, and recall. We have set the thresholds there. If there is a, if there is a precision or recall below the threshold level, then there is a, a notification that is sent to the owners, and then the owners basically retrain the models. So that's how things work in production level environment. The next question is, when working with a classification dataset that has over 1,000 features, what methods would you employ to reduce it to just 5 to 6 features for lower dimensionality? Now, if you are asked this question, potentially the interviewer is interested to know more about your feature selection and feature engineering processes, and he also wants to know whether you have come across such situation or not, right? Now, how would you answer is, of course, as I told you, for each and every question that we are answering in this interview series, every question has to be answered based on your own experience, right? Because in that case, you will be able to relate to what you have done in the past, and you will be able to more truthful in in that scenario, and potentially will be able to handle some counter questions that you are getting from the interviewer, right? So always make sure that you answer from your own experience. Now, from my experience, how would I basically answer this question? So, um, the way I will answer is I will try to relate this with one of my previous examples or previous models that I have worked in the past, right? So, sir, so in the past, actually, I have worked on multiple classification models. Maybe I'll just talk about one of the models, which is a voice analytics related model. So it was basically a deep learning use case, but I'm not jumping into the deep learning part. Uh, Classifying voice data. So I'm not jumping into the deep learning part. I'm directly talking about the machine learning part. Well, the original data was in a different format, audio data. We actually used Fourier transformation to extract all the spectral information, spectral density, and various other MEL filters. So eventually, we were able to get a huge Excel sheet, right? Where there were a lot of features, like there were more than 150 features, and of course there was a y variable talking about whether the patient is healthy or unhealthy, right? So the use case was based on voice data. We were able to identify whether a patient or a person is healthy or unhealthy, right? So the processes before this is very simple. It has nothing to do with this particular question, but let me just quickly take 1 minute to explain. The originality is basically a audio data. From audio data, using Fourier transformation, we are basically extracting all the information in an Excel format, like spectral density, spectral centroid, MEL filters, blah blah blah. All those information are being fetched. There are some Python libraries for it, and then this data already has labels like healthy and unhealthy, and then we take the normal steps like testing and training split, and then calling the models, right? So whenever from the front end application, whenever you hear a voice from the front end application, you are actually taking the voice, doing the same Fourier transformation technique, getting the tabular format data, and then you are calling the model.fit, model.predict, and then you are predicting whether it is healthy or unhealthy. That's the entire use case, right? Now, talking about features, so basically what you're asking is how are we doing dimensionality reduction, right? Dimensionality reduction, right? In this case, we were able to reduce from 150 to around 7 8 features. Now, the reason why we did was, um, I mean, it was multiple reasons. Of course, low dimensions are always preferable because it is faster, cost efficient, and memory efficient, CPU utilization efficient, and all those things. But in our case, uh, I mean, we were able to get good amount of accuracy beyond what was mentioned in the research papers in just 7 to 8 features. Now, talking about this particular question, how would I approach a problem where we have 1,000 features to get it down to 5 to 6? There are multiple techniques, right? So one of the techniques is following traditional approach. Recursive feature elimination is one of the processes, RFE, where we have to eliminate features one by one. Like we have 1,000, and then we eliminate one of the most irrelevant feature. Let's say we are doing some correlation with respect to the y variable, and we are, let's say, storing all the numbers, right? And whoever is having the worst correlation, I will be removing that first. I mean, I'm just giving you an arbitrary step. on how traditional techniques work, right? Apart from that, there are also some feature selection processes within the algorithms. Let's say random forest already has a concept called as feature importance, right? So if you're using feature importance from random forest, you will potentially be able to get the list of first 5 or 6 features that are important. But when you are only selecting these 5 or 6 features from the 1,000 features, the model's performance will deteriorate. I mean, this is what I'm telling from my experience, because you are removing 995 features which could also contain a lots and lots of data and information, right? So model performance has to deteriorate. There is no other way. Now, especially in this example, cutting down from 1,000 to 5 to 6, I would recommend to go ahead with a proper dimensionality reduction technique. So there are multiple techniques like PCA, LDA, QDA, and KPCA. Now talking about full forms: principal component analysis, linear discriminant analysis, quadratic discriminant analysis, kernel PCA, right? Out of these four, blindly see any of them could be the best one. Of course, we can actually apply multiple one by one and see which one is good. But my gut feeling is that PCA usually works really good for nonlinear data sets. So basically, I will be going ahead with PCA, and inside PCA there is something called as n components. So I will be using just, let's say you are taking 5, so I'll be taking 5 components. Now here it depends. So basically, if you are confident in this topic, focus more on that part. If you are not confident on this topic, potentially touch base and focus on those parts which you are confident on, right? But imagine I'm pretty much confident on PCA. If they ask me about PCA, I can actually explain them what PCA is all about theoretically, and that will be really good for me because I can talk 30 minutes, 1 hour on PC, right? So if you're confident on PC, completely fine, you talk more about it, because of course this is one of the most important ways, but only pitch them the topic if you are confident on it, right? Now PCA, basically what does it do is it actually takes 1,000 features and creates its own features, right? That means it's actually taking all the features into account and creating its own components: PC component 1, PC component 2, PC component 3, PC component 4, PC component 5, right? And it's a mixture. Like, you cannot really say that PC component 1, out of these 1,000 features, PC1 is a mixture of all of this, PC2 is also a mixture of all of this. And how the PC components are created, that's another story. If you want, I can talk about it by taking a simple example on how to create 2 principal components, because that is what I can draw on screen. 5 principal components not possible to draw. So this is how you pitch your answer, right? So now the interviewer understands that you know the traditional approaches, you know this, right? Again, from this topic, there could be different areas where the next question could be coming from. It could be from correlation. Okay, what about correlation? How do you do correlation with respect to y variable, and why correlation is important? Why not some other techniques? Why not applying some other statistical tests to identify the best features? So these kind of things. Random forest, why do you prefer feature importance? Why PC over LDA? Why not LDA? Can you talk more about QDA, how QDA would work? So any follow-up question could come from this topic, but the answer of this particular question is this one. So these are the different techniques using which you can lower down the dimensionality. And again, as I said, in machine learning there are hundreds of answers. If you have a different answer with respect to what you have experienced on, feel free to answer that. So the next question is, can you describe some feature encoding techniques you have implemented, along with examples of situations where each technique is most effective. Now, again, the idea of this question is very simple. Interviewer wants to know about your knowledge on encoding techniques, right? I mean, most of the people know about label encoding, most of the people know about one hot encoding, but very few know about more than that, right? So here you have to first of all, you have to start answering about what are the different encoding techniques, and you have to give them examples on how you have used them in your previous experience or your previous machine learning model building exercise or your use case, right? So to get started with, probably I'll talk about some of them. I'm not going to talk about each one of them because there are eight or nine or even more than those kind of encoding techniques. The first one is label encoder or label encoding. Then we have one hot encoding. Okay, one hot encoding. Then we have dummy encoding. We have hash encoding. We have binary encoding. We have target encoding, and we have few other types of encoding techniques as well, right? Now, in the space of machine learning, we usually do not use a lot of encoding techniques because one, two, or maximum three type of encoding techniques are more than enough, right? Now, first of all, what is label encoding? Label encoding is as simple as, let's say you have a gender column and you have a male and female, you just label it as 1 and label this as 0. That's it. This is label encoding. So usually we do not use label encoding for any of the x variables. No, because in that case the model will be biased towards male than female, because male is 1 and female is 0, right? So label encoding is only used for target variables. One hot encoding. What is one hot encoding? One hot encoding is, let's say you have a column called as city, right? Let's say Mumbai, Delhi, Mumbai, Hyderabad, Delhi, Hyderabad, right? In that case, how many values are there? Mumbai, Delhi, and Hyderabad, right? So you create three different dummy variables or three different new variables: city underscore m, city underscore d, and city underscore h, right? So wherever you see m, 1, rest as 0. Wherever you see d is 1, rest is 0. And this is how you fill. Now eventually what you are having is three new features which are in the format of numerical attributes, and you can now easily discard them, right? Because it's of no use. Oh, one thing I forgot, the basic thing. First of all, try to answer why feature encoding techniques are used, right? Why it is used? Simple answer: machine learning models eventually are trained on computers, and computers don't understand categorical data, right? They only understand numbers. So when you have data where you have huge amount of categorical data like gender, like city, like various other things, how do you convert them into numerical attributes so that you can pass the data to the machine learning models, right? You eventually have to encode them. So that's why we have feature encoding techniques, and these are the different encoding techniques. Now, in one hot encoding, three new features are created. You can see CTM, CTD, and CTH. Of course, for a new transaction, if the customer is having Mumbai, then of course his values will be 1, 0, and 0. Right? That is one hot encoding. Dummy encoding basically tells you that in this case, why do you need the third column? You can arbitrarily discard this, this, or this, any one of them. Let's say I'm going to discard this. Why? There is a concept called as dummy trap. Okay, it basically tells you that this column is pretty you know, what do you say, like not getting that correct word. uh, it's already predictive, as in, if this is 1, this is 0, obviously the third one will be 0, right? If this is 0, this is 1, obviously it will be 0. So this third column is quite obvious, and it could be anything. It could be this, this, or this. you have to remove one of them because of dummy trap. So instead of n variables, you are basically going to use n minus 1 variables, and that is dummy encoding. So one hot encoding and dummy encoding are very close to each other. You can use any one of them, but dummy encoding is more preferred as compared to one hot encoding. And dummy encodings are mostly used for all the x variables, right? Now, if one of the x variable is, let's say, gender, where you have m and f, there also you can use dummy encoding. So one of these columns will be removed, right? And there will be one column which is gender underscore m. It will be 1 in case of male and 0 in case of female, as simple as that. So it is also very similar to label encoding in this case particularly, but it's okay because eventually your model does not know that it's gender, right? So label encoding mostly used for target variables, one hot and dummy encoding used for x variables. Apart from that, there are binary encoding, target encoding, hash encoding, various other things you can explore by yourself, and you will be able to answer this question. This is a very, I would say, like a very beginner friendly question, not usually asked for people with more experiences. But yeah, that's it. A question is a question. Can you explain the distinctions between bagging and boosting, and in what scenarios would you choose to use each method? Very important question asked in interviews, especially when interviewers want to know about ensemble learning, when interviewers want to know about how many models did you try out when you were building a machine learning classification model or a regression model. Did you just use naive Bayes, decision trees, and couple others, or have you also explored the bagging classifiers and the boosting classifiers, and in which scenarios we have to use which one? So let's try to answer this. Now, if you are getting this question, for sure you have to start with this thing, right? So basically, when it comes to bagging and boosting, first thing what you need to do is, well, these two are ensemble methods or ensemble learning methods, and these are used especially in scenarios where traditional standalone models fail. Now, for example, I'm working on a classification problem, right? I have a data set. I am dividing the data set into training and testing. I have done my feature engineering and feature selection and all those things. And then I am working on models. Model 1, Model 2, Model 3. Now let's say my Model 1 is a decision tree whose accuracy is, let's say, 70%, right? Let's say Model 2 is my naive Bayes classifier whose accuracy is around 72%. And my third model is, let's say, same decision tree with some other configurations, or maybe we'll talk about support vector machines, right? And let's say its accuracy is around 68%. Now, in scenarios where your standalone models or traditional models are failing, ensemble learning comes into picture. And especially there are two types of ensemble learning. One of them is a bagging, one of them is boosting. You might have heard about random forest. Random forest is nothing but a bagging classifier. It's part of bagging, right? Now, first of all, explain what is bagging, and then explain what is boosting, and then try to talk about the differences between bagging and boosting, right? So how does bagging work? Bagging simply works in this fashion, right? Let's say I'm talking about a random forest classifier. Same, I have a data set, let's say 1000 records. I divide the data into 800 and 200, right? And I do my feature engineering and blah blah blah. Now this is my model 1. Now my model 1 is nothing but a decision tree. Model 2 is a decision tree. Model 3 is a decision tree. And let's say I have model N, which is also a decision tree. Now what you do is, all the decision trees are trained, and imagine out of these 800 records, these decision trees are trained randomly, and imagine you have 20 features here, right? Let's say my first decision tree is trained on 200 records and 5 features. Second decision tree, 400 records and 10 features. Third decision tree 600 records and 12 features, and dot dot dot, let's say the last decision tree 250 records with 5 features. Now the number of data points and the number of features are completely random in nature, and that is the reason why it is called as a random forest, right? In random forest, there is randomness in selecting the data points from the training data, there is a randomness in selecting the features from the training data, but all the models that you are using is going to be decision tree model. On top of this, when each of these decision tree is predicting, what you're going to do is you're going to take an average of that. So let's say the final average is, let's say, uh, so let's say for one of the records, one customer record comes in, this model predicts as churned, churned, not churned, dot dot dot, churned. Let's say most of them have predicted as churned, the final output is going to be churned based on a voting ensemble technique. And this type of ensemble technique is called as bagging. And you can see the model building is done here serially, right, in series. If you remove decision trees and you generalize, let's say my first decision tree, my first model is basically a decision tree, second model is a knife based, third model is a SVM, and so on, that will be another bagged classifier. Maybe you can call it as a voting ensemble classifier. It's also a part of bagging, right? Now let's try to talk about boosting. When it comes to boosting, boosting is a little bit different. Okay, now let's say boosting. What happens in boosting is, let's say you have 1000 records, and same you have 800 records of training data, 200 records of testing data, right? Randomly you take some data points. Let's say you are taking 200 data points and you have created a bag, right? And here you are going to test from some of these records. Let's say you're testing from 100 records, and out of 100 records, let's say 50 records failed. That means wrong prediction. So what happens is, when the next bag is called, this 50 goes into the training data, as in for this model, and again randomly some data points goes here, and this model 2 is trained. Model 2 is again tested on a different set of records, let's say 100 more records or 200 more records, and out of them, let's say there are 50 failures or 60 failures. Now this 60 failures goes into the next model, and that's how the process goes on. And you can see it's a step by step process. Model 1, and then model 2, and then model 3, and then model 4, right? So boosting and bagging are, that's what I explained to you. Now bagging helps you to, the differences are very clear. Bagging helps you to reduce variance, and boosting helps you to reduce bias. Now a follow-up question could be why. Very simple answer. When it comes to bagging, right, individual models have high variance, right? Imagine the variance, mathematically speaking, the variance is, let's say, this, right? Eventually when you are calling different models, like in this case there are n number of models, right? So what happens is the variance is averaged out to sigma square by n, so that means the variance is reducing. Similarly, in boosting, individual model have high bias, and when you are running it, like you can see the failures are taking into the second bag, then second bag's failure into the third bag. Eventually, when your initial model, like the first model here, the bias will be too high, and slowly the bias will decrease, right? So this is a very theoretical difference between bagging and boosting, but practically speaking, if somebody asks you which of these models are best, right? See, evolution wise, you know how human beings have evolved, right? Maybe you can just Google out an image, evolution of man, of human. So evolution of human is something like this, right? Now you can relate this image uh, with this particular question. Now if somebody asks you, so let's say this is your traditional methods, let's say decision trees. Okay, now let's say this is your bagging, you can call this as your boosting, which basically means that boosting is a better approach because individual models are weak learners, and the combination of weak learners basically makes it a strong performer. So boosting is theoretically better than bagging, but practically speaking, when you are working on a classification model, you have to arbitrarily test each of them. That means when you have a data, you divide the data into training and test, you do all the feature engineering processes, and when you call the models, you have to call the basic models, decision trees, naive bayes, SVMs. You also have to call random forest, you also have to call different boosting algorithms, and then you check the accuracy which one is performing good. Trust me, there are certain cases, industry level cases, where I have worked on random forest has given better results than boosting. But you can see random forest is here, boosting is here. Logically, it should not give. But there are cases, there are scenarios, there are use cases. So your answer to the interviewer should be something like this. We have to do a hit and trial, check individuals' performance, and then we will be able to get the best model. But with my experience, you can tell the interviewer, with my experience, I feel that XGBoost or AdaBoost, some boosting algorithms will somehow outperform other models. But again, we have to test it out. Explain bias variance trade-off in machine learning and how do you address it? One of the most important questions when it comes to machine learning. Now, out of 100 interviews, at least in 20 or 30 interviews, this question has to be asked. Very, very common question. Now, let's try to understand what is bias and variance, and then we will try to take some examples and try to explain what is the trade-off, bias variance trade-off, right? So, first of all, the Wikipedia definition is bias error is an error from erroneous assumptions in the learning algorithm. High bias can cause an algorithm to miss the relevant relationships between features and target outputs. Now, if I have to simplify this, bias simply means the inability of machine learning model to truly understand or capture the relationship in the training data, right? If you talk about data, there are two parts, right? Training and testing data. So bias basically means the inability of the model to capture the relationship in the training data. Okay. And what is variance? Variance is an error from sensitivity to small fluctuations in the training set. High variance may result from an algorithm modeling the random noise in the training data. Again, in simple terms, variance is nothing but the difference in the error between the training set and the testing set. Let's try to take three different scenarios and then try to understand more about the bias and variance trade-off. Now to explain this concept, let's try to draw few diagrams. So I will name it as model 1, model 2 and model 3. Okay. So let's say I'll try to copy paste it. So what I'll do is I'll just copy paste it. Done. Now the first model is let's say like this. The second model is like this. And the third model is like this. Okay. Now okay. Let me also draw a few more points so that let's say I draw a few more points. Okay. I let it be. Let it be. It's okay. Now, In this scenario, there are three different models, right? Now, talking about regression, I think you must be already knowing it. Let's assume this as a linear regression model. Assume this as a polynomial regression model, and this is not a linear or a polynomial regression. So let it be like a model 3. Okay. Now, in this case, if I have to ask you, now talking about the general definition, right? The general definition is bias is nothing but the inability of the model to capture the relationship in the training data, right? And variance is, let's say, the difference between the error in training versus testing data, right? These are my layman's term definition, right? Now, if I have to ask you here, in among these three models, which of these model has a high bias? Now, inability of the model to capture the relationship in the training data. Now, M3, you can see the data, like the best fit line goes through the training data, right? So this is a case where you can easily say that it is performing really, really good with training data. So you can mark it as a low bias. Among these two, you can see that, let's talk about the first model. You can see the line is little bit far from the training data points, and here the line is bit closer to the training data points, right? You can see the error is less, right? And here the error is little bit high. Imagine there are some data points here, the error will be high, right? But let's say here, let's say the data points are here, the error will be less, right? So model 1 is basically a scenario of high bias, and model T, you can call it as a medium bias. Now talking about variance. Variance basically means the difference between the error in training versus testing data. Now look at model number 3. Model number 3, the training error, I'm writing down as TRE, is 0. Why? Because the line goes through the training data, right? And the testing error is high, right? Now what is the variance here? The variance is quite high, which is quite high. So you can call it as a high variance. Similarly, the first model, there are some good amount of training error and good amount of testing error, right? But eventually they are very close, right? The training error is also like medium and the testing error is also medium. If you take a difference out of it, they will eventually have a low variance. And the model 2 is going to be having medium variance. So model 2 is neither performing good in terms of bias or in terms of variance, but it is like a medium model. Model 1 has a very bad flaw, which is it's very high bias. Model 3 has a very bad flaw, which is having a very high variance. Now, coming on to this topic, many of you might have known about these two jargons, right? Which is overfitting and underfitting. If you know this concept, try to pause this video and try to answer yourself. What is overfitting? Overfitting is a scenario where your model is working perfectly good with training data. Let's say your training data accuracy is around 90%, but your testing data accuracy is around 40%. Or in other way, your training data error is very, very low. Let's say 10. Your testing data error is very, very high. Now this is a scenario of overfitting. So in this case, your model number 3 is prone to overfitting. Working really good with training data but bad at testing data. Underfitting is a scenario where it is, neither good with training data nor good with testing data. So you can call this scenario as an underfitting scenario. Now M1 is bad, M3 is bad. So M2 is basically like a sweet spot or a sweet model which has a medium bias and medium variance, and that is basically the bias variance trade-off. Very important concept. The more you try to explain them, the more the more fruitful the interview will be, and that's it. In case you want to drag in more, of course you can get started with basics of linear regression and then talk about polynomial regression, but that will be too lengthy, so it's up to you. But this is how you answer the bias variance trade-off. How do you handle missing values in a data set? Very important question, very basic question, and the answer should not be memorized. You can always take reference from this video, but my recommendation is always answer based on your past experiences. So if you have worked on a particular use case where you actually had missing values, take examples from your experience, because it is always good, because you were the one who built that model, right? So you can basically counter the follow-up questions. If they have a follow-up question, you will be able to counter it, right? But generally speaking, yes, how to handle this, you can get started with handling missing values is one of the most important concepts when it comes to building a machine learning model. Because see, the very first step is data collection, right? Collection of data. Now once you have collected the data, the very next step is data preparation. Now data preparation is where you are actually preparing and cleaning the data, right? Now in this process, if your data is not clean, you potentially will not be able to go to the next step, right? And the next step is eventually EDA, exploration of data. See, this data cleaning cannot be done 100%. There can be scenarios where you think that your data is clean, you move on to the EDA part, and then later on you realize something is wrong. You again have to come back to step number 2. It's possible, because this is basically a iterative process from 2 to 3 and 3 to 2. So you can always go back, and eventually once your EDA is done, then comes your machine learning model building, right? So in this particular step, handling missing values comes, handling invalid data types comes, a lot of issues comes, right? Now I'll talk with experience with respect to one of my previous examples. So there was a column where we had missing values. So the column was age, right? Now as age is nothing but a numerical column, and we know that the most basic common ways of imputing missing values are mean, median, and mode, right? So these are the concepts of measures of central tendency. What is mean? Mean basically calculates the average value. So let's say you have 10 records. Some of them has a age of 28, 30, null, 31, 25, null, 24, and so on, right? Now in this case, what is the average? The average is 28 plus 30, which is 58. 58 plus 31, which is 89. 114, 138. 138 divided by 5, so which is 2387, right? 27 point something. So you impute them as 27, right? This is a way where you impute using mean. Median, how to impute? So you have to take the numbers 24, then 25, then 28, then 30, then 31. The middle number is 28, so you impute it using 28. Mode is generally used for categorical data. Now if you ask me which of these techniques is best, mean or median, well, there are some statistical answers to it, but those are again very theoretical answers. Practically speaking, what we usually do is like this is what I do is let's say I take the mean, because eventually you do mean or median, eventually your model's performance is not going to be impacted hugely. For example, it will not be like if you use mean, your accuracy will be 80%, and in median, your accuracy will be 90%. No, it will be marginally different. So it's your call whether you want to invest a lot of time in identifying which is the best way to impute, or you focus more on your feature engineering and hyperparameter optimization steps, right? I hope you're getting my point. But theoretically speaking, the best way to do is you impute using mean, go ahead with the rest of the steps, check your model performance. Let's say your decision tree is performing with 81% accuracy. Come back, do with median, and again go with the other steps and see whether your model has deteriorated or increased. Now, if it is increased performance, that means median is better than mean. As simple as that, right? There are scenarios where we also have columns with more than 60-70% missing values. So there was a column called as salary, just taking examples, right? It had like 70% missing values. So in that case, you can actually discard this entire column, because if you are imputing 70% of the records, that means it makes no sense. But there can be scenarios where your column is actually dependent on another column. Now, for example, there is a column called as car type, right? So car type, let's say one of the record is XUV, null, null, SUV. Honestly speaking, I have no idea about the car types. I'm just giving a random example. Null, null, SUV, null, null. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, when you see this column, you can see 30% records are there, 70% records are null, right? So if you follow your normal gut feeling, you can randomly reject this column. But using your domain knowledge, you have to find whether there is a column that is actually impacting this. Let's say you got a column, let's say a column called as is car. Now is car is yes, no, no, yes, no, no, yes, no, no, no. And now you're able to relate. Oh, because the person does not have a car, that's why there is a missing value. Does not have a car, missing value. Does not have a car, missing value. Now when you know there is a column which is impacting this, now you know, right, that you should not remove this column. Instead, what you can do is you can impute it by no car, no car, no car, right? You cannot do a mode. If you do mode, you will have to do it SUV, which sets a bad example, right? You cannot have SUV because this person has no car. So this is how you have to explain using your experience, right? Whatever experience you had in the past with respect to handling missing values, you can always give that. See, theoretically speaking, there is also another way of imputing a numerical column like this. Let's say there is a column, right? Age 28, 30, 31, null, 25, 24, null, 26, null. What you can do is you can use time series forecasting to forecast the next number. So out of these three numbers, let's say you 28, 30 and 31. Your prediction could be like 33 or something, right? So your model predicted 33. Now you have 33, then you have 25, 24. Let's say your model is predicting 28. So you give it as 28. Now what you have is you have this number. Now your model is predicting 25, 26, 25. What I'm trying to say is this is a multi-step prediction process. So what happens is when you have the initial three records, you take these three records, you are predicting this. Let's say the prediction is 33. Next time you are taking all of these and predicting the next one. Let's say it is 26. Next time you are taking all of this and you are predicting this one. Now this is again a theoretical process. In practicals, in my 10 years experience in data science, I have never done it because this is a tedious process. As I told you, I rather would like to invest my time in feature engineering and in hyperparameter optimization because I believe I can have a larger impact increasing the model's performance by fine tuning those processes rather than investing my time in imputing the missing values. That's my stake. But as I told you, in the field of machine learning, there can be hundreds of answers. Feel free, whichever answer suits you based on your experience, you can answer it. Welcome to this first scenario based question. Now, this question is related to customer churn prediction use case. For most of you, you might know that customer churn prediction use case, especially in the field of telecom, is one of the most common use cases found on the internet, right? Many people work on it, many people have written down these use cases in their resumes, and people think that it is very, very easy to work on a churn prediction use case. Well, it is easy because on the internet, on Kaggle, you are already getting a data set which is pre-compiled. Like, you already have a data set which is having classes, right? But in reality, getting into that phase of getting the final data set for your machine learning model itself is a challenging process. In my previous experience, when I was working with Hutchison Group for data collection, you will not believe I spent around 4 months of time. It's not like I was just working on this particular model, so for 4 months of time I was just collecting data. No, in parallel I was doing other things as well. But eventually, to get the final list of my document with all the labels and everything, it took me 4 months. But in the internet, Kaggle is already providing you the data set, and then people are just dividing it into training and test, doing engineering, and then calling the models. Simple, right? But it's not like that. In reality, things are different. Now, talking about this particular scenario based question, this is a question that arises from my experience. Now, try to understand this question, pause this video, and challenge yourself to answer this. If not, you can follow this video, right? So suppose you're working on a customer churn prediction model. Okay, so let's say I will take an example of Vodafone. I always take examples of Vodafone. I don't know why, because Vodafone was one of my client in the past with 10,000 records. So you have a data set with 10,000 records, right? Where 2,000 represents churned customers. So for simplicity, I have given a ratio of 20%, right? So 8K active customers and 2K churned customers, right? So what is the churn rate? The churn rate is 20%, right? You split the data into 80% training data. So let's say you split the data into training and testing data. So this is your testing data, this is your training data, right? So in your training data, you have 8,000 records. In your testing data, you have 2,000 records. And assuming a equal split, here there will be around 6,400 active customers and 1,600 churned customers, right? 80% of 8,000 is 6,400. Similarly here, how many active customers? 1,600 active customers and 400 churned customers, right? Now your model is trained up to January 1st, 2025. Okay, let's imagine this data is from 2022 till 2024, right? And your model is trained on January 1, 2025. And these 6,400 active customers are already part of the training data. Fine, this is a part of a training data, and you have already created your model. Let's assume this as a random forest model. Okay. How would you test whether these customers will churn within the next 6 months, considering that their data is already included in the training set? Wouldn't this lead to model bias? Okay. The question is very simple. The question that is asked is, today, let's assume it is January 1st, 2025. You already have trained all of this data, right? You have already trained all of this data into your model, right? That means this 6,400 customers are already part of this training data. But eventually, some of them will churn, right, in the future. 6 months, 12 months, 18 months. So at some point of time, they will churn, right? But right now, if you want to test it on these customers, how will you test it? Because these records are already part of training data. If you test it, it will be biased, right? The model will by default predict as active. So, how will you be able to do a prediction on these records? See, for these records, I don't care because they are already churned. I don't care. I don't want to test it on these records. As part of model training, that is fine. But after the model is trained, I don't need to test out these 1600 records, right? I only need to test out these 6400 records, and of course my testing data, and of course anything that comes new. So for example, in 2025 January there are 1000 new customers. For them also we will do a prediction, but I'm just concerned about these 6400 records. How will you test it out? Because they're already a part of training data. So if you predict, it will be biased. By default, it will do a prediction of active. Pause this video, try to take some time and see whether you are able to answer. If not, you can unpause and check out the answer. So for those you have paused and tried to answer, well and good. If not, let's try to move on and see what potential answer it could be. Uh, so this is a real-time scenario. I'm talking with experience. This is a model that I have built in Hutchison Group. It's already in production. People are using it, right? And so a little bit about before even talking about the solution, little bit more about how this model or how churn prediction model basically works in telecom. Now, before we started working on this model, let me just tell you, because this is very important. Many of you might not know this. So even before we create a machine learning model, telecom companies usually have a very traditional approach of identifying potential churners, right? So there are some pre-sales and sales team in every telecom company, where they basically generate a report. Like, so they generate a customer list every month which has potential churners list. I don't know how they do that. Maybe just with manual calculations and intuition, without machine learning. And what they do is they basically have a telecalling team who basically calls all of these customers. They tries to identify the sentiment of the customers, whether they are liking the product or not, whether they have a difficulty or not. Wherever they see the customer is little bit hesitating, they are not quite happy with the service, the sales team tries to provide a offer, like a $50 offer or a $100 offer, or maybe a 10 GB free internet offer or something like that. And that's how they somehow retain some of the customers, right? So when we deployed this model for the very first 3 months, the same process happened. Our model was able to predict churners for the next month. Sales team usually have a list. So let's say my model has predicted 2000 customers, example, and sales team has also generated a list of, let's say, 1600 customers. First of all, we will check what are the common customers. Let's say the common customers are around 800 to 1000. So they will be the first priority. So telecalling team will call them, and there is a whole process of retention, right? Giving them offers. Now coming back to this topic, which is a very important topic, which is how will you test the data points that are already part of the training data. Now remember one thing, I told you that model was built on January 1st, right? With data from 2022 to 2024. Now imagine you are doing a 6 months prediction, right? So your data is still January, fine, but you are doing a prediction for May, June, or July, right? Let's say you are doing a prediction for June, right? Now in your raw data, there could be certain features which are time dependent, right? Features like tenure, features like age, right? And features like um, recharge date or maybe some usage metrics. Now they will vary with respect to time, right? Let's say January 1st, X customer's tenure was like 12 months. But when you are doing a prediction, you are doing a prediction for 18. Similarly, let's say the age is like in months, the age is like the candidate, the customer is 24 years old. So 24 multiplied with 12, which is 288 months. And now the new feature is 294. Right? Now these features are changing. So when these features are changing, model will not be able to identify that you are basically doing a testing on the same customer because the features are changing. Imagine there is a customer out of this 6400, there is a customer, right? Mr. Satyajit, right? His tenure is 12, his age is 288, he stays in Bhubaneswar, he has a salary of 15,000. Let's say these are the features. Let's say after doing a encoding, let's say you remove this feature, not important. So you have one feature which is 212, 288. Let's say BBSR is encoded to, let's say 1000, and then 15,000 is 15,000, right? Of course, you will go through a normalization and standardization process. So these are not going to be the raw numbers. But just imagine this is your original data point, which is a part of your model, right? But when you're testing it, you can see the features are going to be like this, right? So the features are changing. So this is like a new data point for the model. So model will be able to identify. Okay, this is one of the potential answers, and this is what we did. There could be another potential answer. So imagine you have hundreds of features. I don't mind. What you do is you can simply create a PC model with let's say 4 or 5 components. That means if you have hundreds of features, you are cutting down to 4 or 5 PC components, right? And when PC components are created, everybody knows the concepts of principal component analysis. They basically create new components. They are not like leveraging some of the features from this 100 list, right? They will be creating complete new features. So PC components are created. So when you have a new data point, so if you create PC components, the data points will be completely different. So model will not be able to identify these are the same two records that are already a part of the training data. So no problem in that. So this is how you tackle these kind of questions. And scenario based questions are also very commonly asked in interviews. So make sure you prepare them, and it comes with experience, right? When you start giving interviews, multiple interviews, 4 5 6 7 8, eventually you will be get used to these kind of scenario based questions. When you get such questions, think patiently, take your time, and do some pen and paper architecture diagram or something, and eventually you will be able to solve it, I believe. Let's move on to the next scenario based question. So suppose you're working on a fraud detection project. Eventually your task is to identify frauds, to detect frauds involving nearly 1 million transactions, but you do not know how many of these transactions are fraudulent. How would you approach solving this problem? Now this problem can be restructured into a very simpler way, which is, let's say you want to work on a fraud detection model, but you do not have labeled data. That means you do not know which of these transactions are fraudulent and which of these transactions are not fraudulent. Now as a machine learning engineer or as a data scientist, how would you approach this problem? So there are multiple answers to this question. This is not a very straightforward question that you will be following a rule book and you will get the answers. No, there are multiple ways of solving it. This is again one of the live case studies that I have solved in the past. And how did I solve? I will teach you my way of solving it. Okay, and that's how you can answer in the interviews as well. Just in case you cannot think of any other ways, you can pick my answer. So in my previous company, one of the companies where I worked for almost 3 months, I left it uh, because I got a better opportunity in another organization, in a stronger position, so I left. But this company was a cybersecurity startup company. I will not name the company, but in that company, yes, this was a use case. Now, in the company, we already had cybersecurity experts. Okay, so cybersecurity experts are already there. So even before machine learning comes into picture, right, there were certain traditional ways of identifying frauds, right? Because cybersecurity team already might have a set of rules based on which they can easily identify whether a transaction is fraudulent or not. Machine learning is just trying to automate it. It is just trying to learn the past transactions and trying to predict whether a new transaction will be fraudulent or not. As simple as that, right? So the way I started with this solution is, firstly, I took 1 million transactions, right? Now, I'm not going to talk about the data collection part, assuming that the data is already structured in an Excel format or maybe directly coming from database. So I have 1 million transactions, right? So I already have the data. And there are multiple features. Of course, using my knowledge, using my cybersecurity experts knowledge, we were able to fine tune and then finalize the number of features that are going to be used for this use case. So the very first step was I treated it as a semi supervised learning problem because first of all there is no labeling. In order to create a classification model, first of all you have to label it, right? And second of all, you cannot go to the cybersecurity expert and tell him to label it, because going through 1 million transactions is very difficult, right? And because of which we took a step, we basically created a clustering algorithm. So for simplicity, I will write it down as, let's say we were using a k-means clustering. Okay. Now using k-means clustering, we were able to identify the value of k. I do not remember the exact number of k, but let's assume the k value as 5. Right. Now, how do you get k value? If you know k-means clustering, you must already be knowing there is a elbow method, right? Right. Number of clusters, WCSS, right? With, sorry, my bad. uh, yeah, number of clusters. No, number of clusters is here. Number of clusters and WCSS, right? For number of cluster 1, the WCSS is high, and then it simply goes down, and goes down, and something like this. Wherever there is a elbow formation, that is treated as a potential K value, right? I'm not going to go through the concepts of WCSS and all those things. In case you want to explain the interviewer, well and good. But in short, what is WCSS? Within the cluster sum of squares, right? That means if you have a data point, like if you have a data set, let's say these are the data points. If you have one cluster, the centroid will be here, the WCSS value will be very, very high, right? If you have two clusters, let's say here, one centroid will be here, somewhere here, one centroid will be here, and the WCSS will go down. The more clusters you have, the WCSS value will eventually go down, and the graph will look like this. Wherever there is a elbow formation, you can treat that value as a potential K value, right? So in our case, we choose K, and then we kind of converted all the features into PC components. So two-dimensional PC components, which is PC1 and PC2, and on top of that, let's say I have like 5 clusters. right? Now what we did was we kind of selected the smallest cluster, right? In the smallest cluster, we basically involved the cybersecurity expert to label them, because smallest cluster is easy to handle. It must be having 1,000, 2,000, or 10,000 records. The cybersecurity expert can sit like for 2 or 3 days and label them. Once the labeling was done, then using that as a label data, we basically trained a machine learning model and we tested it on the second cluster. Now, on the second cluster, the test results that we got, we also went to the cybersecurity expert, asked him, we have got some results, just try to validate them. You need not have to label them, just validate them, and he will validate. And similarly, we will have two different label data. Eventually we will go to the third cluster, then the fourth cluster, then the fifth cluster, and that's how we will be able to find the final labelings. And once we have the final 1 million records labeled data, then we will again involve cybersecurity expert, ask him, check out your rule book and see only the fraudulent records, whether these make sense or not, are they accurately done or not. Eventually it will not be 100% accurate, but at least we have something to work on, right? Initially we had no label data, now we have label data with the help of clustering, right? Another answer could be that, so out of this 1 million transaction, as your domain knowledge, you might be knowing that, okay, let's say you have around 1 to 2% of fraudulent records, and 1% of 1 million is around 10,000, right? 10,000, yes. So another solution is, when you are doing the clustering, let's say you find this cluster as 9,000 records. So this could potentially be your fraudulent transactions, potentially. Again, validation is needed by the cybersecurity expert. Okay, but if you answer this way, your interviewer might ask you back that, what if there are, in the range of 9,000 to 12,000, there are multiple clusters? How will you identify which one of them is a fraudulent record or a fraudulent cluster? So in that case, you might not be able to say. Again, you might have to answer it in a way that, yeah, I will be involving my cybersecurity expert to validate them, right? So once you have the, eventually using this process, once you have the label data, then life is simpler. Then you directly go ahead with the data set, divide the data into training and test, do the feature engineering processes, and try out multiple models, test it out. Whichever model is performing good, go ahead with the hyperparameter optimization, and here you have the final model. And that's how you need to answer. This is a very classic question asked in interviews. There are different ways of answering it. I just explained you one or two different ways. There could be a different way of answering it. But yeah, if you have experience, if you have knowledge on these kind of questions, answer based on your knowledge. If not, you can pick my answer. Thank you all for watching this video till the end. I hope this video was insightful. If it was, please like, share and subscribe the channel. And coming on to the major announcement, our team has dedicatedly worked on couple of ebooks on machine learning, on deep learning, on generative AI, and they have curated the top 100 interview questions that can be asked in each of these domains. On top of that, we have also added scenario based questions that are actually asked. Either it has been asked to me or some of my team members. So those are real interview questions. And in case you want a copy of it, just write down ML ebook as part of the comments, and we will be releasing you the machine learning ebook. About other ebooks, they will be released when those corresponding videos are released on the channel. Apart from that, in case you have any other questions, any other feedbacks, you want to discuss with me on any other topic, you know what to do. Leave a comment and we will reach out to you. That's it. Satyajit Pattnaik here, signing off. See you in the next video. Till then, bye-bye.